Microsoft Azure is made up of data centers located around the globe. These data centers are organized and made available to end users by region. A region is a geographical area on the planet containing at least one, but potentially multiple data centers. These data centers are in close proximity and networked together with a low latency network. For most Azure services, when you deploy a resource in Azure, you have to choose a region where you want to deploy your resource. A few examples of these regions are West US, Canada Central, West Europe, Australia East, and Japan West. Azure has more global regions than any other cloud provider as on today. This provides the customers the flexibility and scale needed to bring applications closer to users around the world, preserving data residency and offering comprehensive compliance and resiliency options for customers. Azure is generally available in 42 regions around the world, and it has 12 more regions planned and announced. Azure also has some special regions that you might want to use when building out your applications for compliance or legal purposes. These special regions include the U.S. Department of Defense Central, the U.S. Government Virginia, and U.S. Government Iowa. These are physical and logical network isolated instances of Azure. This is specifically for U.S. government agencies and partners. They are operated by screened US persons, and that includes compliance certifications. China East, China North. These regions are available through a unique partnership between Microsoft and 21viaNet, whereby Microsoft does not directly maintain these data centers. Germany Central and Germany Northeast. These regions are available through a data trustee model whereby a customer data remains in Germany under the control of T-Systems, which is a Deutsche Telekom company acting as a German data trustee. Any user or enterprise who needs their data to reside in Germany can use this service. Each Azure region is paired with another region within the same geography. This approach allows for replication of resources. This replication of resources like virtual machine or storage is done across the geography that helps reduce the likelihood of interruptions that are caused due to events such as natural disasters, civil unrest, power outages, or physical network outages. Additional advantages of regional pairs include, in the event of wider Azure outage, one region out of every pair is prioritized to help reduce the time it takes to restore them for applications. Planned Azure updates are rolled out to paired regions, one region at a time. This is done to minimize downtime and risks of application outage. For compliance purposes, data will continue to reside within the same geography. For example, data in United States will not go out of United States, and same goes for Southeast Asia or European region. Examples of regional pairs are as shown in this URL. Asia is paired with East Asia. China is paired with China North 2. Germany Central, and Germany Northeast. So please click on this URL and notice the paired regions for each geography. When provisioning services like virtual machines, storage, traffic manager, or Active Directory, remember that not all features are available in all regions. There are certain services that are available in certain regions only. For example, certain virtual machine sizes or storage types are available in certain regions and probably not in other regions. On the other side, there are certain services which are global services that do not require you to select a particular region. For example, Microsoft Azure Active Directory, Microsoft Azure Traffic Manager, or Azure DNS. These are certain services that are available in all regions. They do not need to have a region at all because they are available globally. There are certain services that are not available in other regions. You may have to take a look at this URL here to find the region versus feature availability, to see what feature is available in what region, what virtual machine size is available in what region. When provisioning services, always make sure that you take a look at this URL before you commit to your customer about the resource availability in a particular region. We now know about geographies and regions. Let's understand what availability zones are. Availability zones are physically separate locations within a region. Each availability zone is made up of one or more data centers that are equipped with independent power, cooling, and networking. It is set up to be an isolated boundary. So that means if one availability zone goes down, the other continues to work. The availability zones are typically connected with each other through very fast private fiber optic networks. Availability zones allows customers to run mission-critical applications with high availability and low latency replications. Availability zones are offered as a service within Azure to ensure resiliency, and there is a minimum of 3 separate zones in all enabled regions. So, availability zones are physically separate locations within an Azure region. They are made up of one or more data centers that are equipped with independent power and cooling and networking. So they're totally an isolated boundary. Now that we know what availability zones are, let's understand what is an availability set. The cloud provider is responsible for the physical infrastructure in their data centers. So availability set is a way for you to ensure that your application remains online if a high impact maintenance event is required. Who does the patching and who does the security updates and maintenance of the hardware? It is the cloud provider. And when cloud provider has to update the hardware, update the firmware of the BIOS, then the whole server goes down. There must be a mechanism by which when the maintenance occurs, the production on the applications are not impacted. This is done through 2 techniques. One is an update domain and other is a fault domain. Let's understand what they mean. Now, when a maintenance event occurs, for example, performance updates or critical security patch is applied to the physical host, the update is sequenced through the update domains. As you see in the picture here, the update domain is not on a single rack. Each grayed box is a rack here, and the update domains are separated across racks. So if the patching happens in a rack, the application is not impacted because there are other update domains that are up and running. So sequencing these updates using update domains ensures that the entire data center isn't unavailable during platform updates and patching. The update domains is a logical section of a data center, and they are implemented with software and logic. And what is a fault domain? Fault domain provides a physical separation of your workloads across different hardwares in a data center. Now, why do we need that? Now, each of these racks or the physical separation has its own power supplies, cooling, and network hardware that supports the physical servers located in the server racks. So in the event that hardware that supports the server rack becomes unavailable, only that rack of servers would be affected by the outage. So fault domains will provide a physical separation of workloads across different hardware in the data centers, whereas update domains is used for scheduled maintenance, performance, or security updates that are sequenced through these update domains. In Azure, you can create different kinds of resources like virtual machines, web applications, databases, etc. The list is just endless. But there will be some point when you would like to group those resources. And that grouping of resources is called as a resource group. A resource group is a unit of such resources in Azure. You can think of resource group as a container that will allow you to keep all the resources inside it. By keeping all the resources inside a resource group, you will be able to manage them more effectively. For example, you can know what is the meter and billing of that resource group. Let's say that that resource group belongs to a business unit called as HR or human resources. At the end of the month, you can bill them based on the resources that are inside that resource group. You can apply policies, monitoring and alerts can be done, Quotas can be assigned, and access control or permissions can be granted on a resource group. A resource group will let you effectively manage the application collectively over the life cycle of the resource group, and it becomes difficult to manage objects individually rather than managing them all collectively together inside a container, which we are calling it as a resource group. So think of a resource group as a container that will allow you to aggregate and manage all the resources that are required by your application, or a single manageable business unit. Every Azure resource that you create must have one resource group associated with it. In the previous video, we learned about Azure Resource Groups. Azure Resource Groups is grouping of resources. But how are the resources created in Azure? The resources in Azure are created through the Azure portal, PowerShell, Azure CLI, REST APIs, or client SDKs. Azure Resource Manager is responsible to deploy the resources in Azure portal. Azure Resource Manager handles your requests that are sent through the Azure portal or through PowerShell or Azure CLI. All capabilities that are available in the portal are also available through PowerShell, CLI, REST APIs, or client SDKs. It is the Azure Resource Manager which handles the deployment and management of services, regardless whether they are deployed through the portal or through the CLI. Azure Resource Manager is a management layer in which the resource groups and all the resources within it are created, configured, managed, and deleted. So it provides a consistent management layer which allows you to automate the deployment and configuration of resources using different automation and scripting techniques such as PowerShell, CLI, Azure portal, REST APIs, etc. The upcoming videos will all be talking about the core Azure services and products that we have as on today. This document that I've opened up here is also attached to the resources section of this video. Core Azure services and products are categorized primarily as compute service, under which we'll be talking about Azure virtual machines, VM scale sets, app services, and functions. Container services, which is also picking up the heat, we will talk about container instances and Kubernetes service. Networking, and very important thing to know, virtual networks, and load balancers, VPN gateways, Azure App Gateway, and content delivery networks. Azure Storage Services is categorized as structured, semi-structured, and unstructured data. Database services is for both NoSQL as well as SQL services and migration of on-premise database services to Azure-based databases. What is Azure Marketplace? How do we handle IoT data and what services Azure is providing as in today? It's called as Azure IoT Hub. How do we handle big data and analytics data? So Azure has 3 different services, and we'll understand the differences between them later on in this video. So we got Azure SQL Data Warehouse, Azure HD Insight, Azure Data Lake Analytics as well. How about artificial intelligence, which is a buzzword these days? So Microsoft Azure's got Machine Learning Service and Machine Learning Studio. Serverless computing is categorized as Azure Functions, Logic Apps, and even Grid. DevOps is another buzzword. So Azure has DevOps services and Dev Test Labs. Services in Azure can be managed with Azure Portal, Azure PowerShell, CLI, and Cloud Shell. And finally, to talk about Azure Advisor. In each one of these sections, we'll be not only talking about these, explaining each one of the functionalities, but also doing labs. So I will show you hands-on demonstration on each one of these services that Azure has. Azure Compute Service. Now, Azure Compute is an on-demand computing service for running cloud-based applications. It provides computing resources such as disks, both SSDs and regular HDDs, processors of different kinds, memory of different configurations, networking, and operating systems. The resources are available on demand, and that can typically be made available in minutes or even seconds. You pay only for the resources you use and only for as long as you're using them. Now, you will use these resources such as processors or memory for creating virtual machines and containers. In the next set of videos, you will learn what virtual machines are and how do you create them using the Azure portal. Right since the inception of virtualization, every piece of hardware has also been virtualized. For example, the processors, memory, storage, and the networking resources that we used to touch, feel, and know about them physically, today they have been transformed to virtual files. Virtual machines are nothing but software emulations of virtual computers. That means everything that is connected to a virtual machine, like processors, memory, storage, and networking resources, are all in the form of files. So the operating system that is hosted on the virtual machine is also running on a hard disk, which is in the form of a file. When using a remote desktop client, you can use that virtual machine just like the way you are physically sitting in front of it. Azure today supports a wide range of computer solutions for development, testing, and running production-sensitive applications, including Linux, Windows servers, SQL servers, Oracle, IBM, and also SAP. Azure has many services that run virtual machines, and each is providing different options depending on the requirements. Some of the most prominent services are virtual machines, of course, app services, and Azure functions. In this video, we'll learn how do you create a virtual machine using the Azure portal. At this time, I'm logged into the Azure portal with my subscription, which is there. You can see on the top right hand side, keeplearningcloud@hotmail.com is my user ID that I've used, and the subscription is pay as you go. When you want to do a similar lab like this, you may need to have your own subscription. You can create your own free subscription, and I'm going to show that to you in the subsequent videos. At this time, let's just learn how to create a virtual machine. Now on the left hand side, you see I want to create a virtual machine, so I will click on the virtual machine section and then click on create virtual machine. You can either click on this blue button or click on this plus icon. That's the same thing. Now what it's going to open now is a wizard that will show us a couple of options that we need to fill up. For example, selecting the subscription, the resource group, virtual machine, etc. So we have to follow this wizard. Microsoft is known to make things easy by giving us a wizard way of installing something, a wizard method of provisioning something. In this case, it's a virtual machine. The first thing that we have to do is select subscription. So if you create your account for the first time, this will not be pay as you go. This will be a free tier account. I will be creating a new resource group. In one of the videos earlier, we learned about what a resource group is. Resource group is a collection of resources so that you can later on charge the business unit back, or maybe apply certain policies, do certain troubleshooting on that resource group. In the previous example, we said that the resource group name is human resources, so you can apply policies and then bill, charge back the HR business unit. In this case, I'm going to create a new resource group because I do not have one. So let's name the new resource group as payroll and say OK. Now what's your name of the virtual machine? Always follow certain standards for creating a virtual machine, and you may have to ask the business unit what their standards are. Now let's name the virtual machine as VM Web 01. There are certain naming standards that Azure itself has. If you look on the right hand side, it says that the resource name cannot contain special characters. Virtual machine name must be unique in the current resource group. The value is in between 1 to 64 character long, and all characters are valid for Linux OS. Looks like I'm compliant. So moving next. Do you remember the picture that I was showing about the world map where we had the Azure data centers? Now as you see here in this picture, the Azure data centers are available everywhere. That's what the next option is about. Where do you want to create this virtual machine? Now all those blue dots that you saw on the map is what these lists mean. So you can select one of these geographical regions. So the best practice is to choose a virtual machine that is closest to the user. Right? So let's go ahead and select East US in this case. I have this habit of selecting East US. Availability options. Remember what availability options were? So if you want to make sure that your virtual machine does not get impacted by any natural disasters, man-made issues, or could be patching, updating the firmware on the machine, things like that. So you may want to choose an availability option to make sure that it's available at all times. But in this case, it's just a test environment, so I'll leave the availability option at this time. The next option is image. What kind of operating system are you looking for? Do you want a Windows, or are you looking for a SUSE, CentOS, Red Hat? You got all of these options. I'm going to select a 2012 R2 data center. The next option is how much of compute power, the size that you want to give to this machine. You got different permutations and combinations. So I'm going to click on change size. Then you will see different combinations available. So this one is D4SV3, which is giving me 4 CPUs and 16 gigs of memory. Although you can choose anything, but I will stick to this, which is giving me 1 CPU and 3.5 gigs of memory. So that's fair enough. I don't need more than that for the lab. Administrator account. Make sure that you choose, or rather say, do not choose a regular name like administrator or root, because Microsoft does not accept it. Let's give it a shot. Administrator. So say usernames must not include reserved words. Even usernames like root are not accepted because these are reserved words. So I'm going to choose root admin. Okay. The password, make sure that it is complex and fits the compliance rules as well. So yeah, password is matching. Make sure that it's long enough, it's complex, it has special characters, uppercase, lowercase, to make sure that the unethical people out there on the internet do not guess it so quickly with their tools. Now this virtual machine is being created somewhere out on the internet, somewhere in Azure, in one of the data centers, which we selected East US right here. So this is a Windows-based virtual machines, and I must be allowing certain inbound ports for us to access it from my network in this case. So I want to allow port number 3389 so that I can RDP to this machine. What's the point of creating a virtual machine in Azure if I cannot access it? So if I want to access it, I need two things. One is an inbound connection allowed on RDP because it's a Windows machine. If I would have selected a Linux machine, I would select SSH. Yeah. Now I also have the username and password. So once this machine is ready, I'm ready to RDP. RDP is remote desktop protocol, which will let us connect to the machine over remote networks. Okay. So in the next section, we can select the disks. How much of hard disk size do you want, and whether you want a premium SSD, a standard SSD, or a standard SSD. The differences between these will be IOPS, or input output per second, or the performance that will be directly related to these options. Premium SSD is used for mission critical workloads that are production sensitive. Now because this is just a test environment, I'm going to choose standard HDD. Other option here is to create and attach a new disk. So this one is just going to create a C drive, but I can have multiple disks attached to it, which will be D, E, and F drives subsequently. Clicking on next, it gives me the option to select the virtual network. Now every time you see new in brackets, that means it is creating a virtual network for you. We have not created a virtual network so far, so hence it is creating a virtual network for me, because in my subscription I do not have a virtual network in East US. So it's going to automatically create a virtual network. But in the subsequent videos, when we talk about virtual networks specifically, I will tell you how to create a virtual network. So it creates a virtual network, a subnet, and is also assigning a public IP to me. Well, I have the option not to do so. So if I do not have a public IP to the virtual machine, I will not be able to access it or RDP to it from the internet. Okay, so hence I will have a new public IP assigned to this. Do you want this virtual machine in a security group? A security group is nothing but a firewall. A firewall will have set of rules that will allow or deny incoming or outgoing connections. In this case, I have selected inbound ports to be allowed for RDP. That means this security group or the firewall will have an ACL written or a rule written allowing me to RDP to this virtual machine. Next, do you want to have accelerated networking that will increase the Ethernet speed so that people can do transactions faster at a networking level? Now, because this is a small size machine, it says the VM does not support accelerated networking. Do you want to have virtual machines behind a load balancer? Now, at this time I will say no, because we haven't touched upon the subject of load balancer, so we'll park it for later discussion. Next is management section, where it talks about where you want to store the boot diagnostics or OS guest diagnostics. So just in case this virtual machine ever falls in trouble or a problem, how would you like to troubleshoot that? Well, for troubleshooting purposes, you will need logs. Those logs are boot diagnostics and OS guest diagnostics. Boot diagnostics are storing logs specifically for operating system boot operations, whereas anything in the application or operating system behaviors will be logged in OS guest diagnostics. Now, both of these are going and sitting inside a separate storage account called as payroll diag 555. Now, again, we haven't spoken about storage account yet. When we talk about storage accounts, you will be able to join these dots. But at this time, please remember that both boot diagnostics and OS guest diagnostics are logged inside a storage account called as payroll diag 555. Consider that as just a storage account, just like your hard disk. Identity section, this is whether you want to join it to your Azure Active Directory or not. Just like the way you join your on-premise system to on-premise Active Directories, here by selecting identity, I'm saying that your system, which is this virtual machine, will be joined to Azure Active Directory. Do you want this machine to be automatically shut down? If yes, then you select on and then select the time along with time zone. Do you want someone to get notified before it shuts down? Well, you then go ahead and put the email address here. Okay, let's just select off here. Now, the last option here is, do you want to enable backups on or off? If you select on, then a new service called as Azure Site Recovery or Recovery Services Vault will be enabled. So all the backups will then go inside that vault. This is good for disaster recovery purposes, right? At this time, I'll select off and then click on the next section, which is adding extensions. Extensions are a way to install clients on the virtual machine or antivirus or anything that will supplement the virtual machine's behavior. On the on-premise infrastructure, remember that we had to install several components like a monitoring agent or an antivirus agent, things like that. So those are nothing but extensions. So I can select an extension to install, and there are a lot of default extensions in this menu. So I can check what I want. For example, if I select an antivirus, I'm just looking for Microsoft antivirus in this case. That's the Microsoft anti-malware. I can just say that. Let's click on it and say create, and just leave these options as default and say okay. Now, during the virtual machine provisioning process, this anti-malware will be installed on the machine. So the installation of anti-malware in this case just goes hands-free. I don't have to do anything, right? So that's what extensions mean. The other options, Cloud Init. This is an approach where you can customize Linux virtual machines, but in this case I really do not have a Linux machine, it's a Windows machine, and that's why this informational message says that the selected image does not support Cloud Init, which makes sense because it is only for Linux virtual machines, right? The other option here is VM generation, whether you want a Gen 1 virtual machine or a generation 2 virtual machine. Now, generation 2 virtual machines are considered to be more secure because it's got UEFI based boot architecture. They can support increased memory. Operating system disk size limits are higher. So generation 2 virtual machines are very good at providing enhanced security as well as better speed and performance. Now I'll click on next to add some tags. Tags are only for charging purposes and bill back, so that people know who owns this virtual machine or which department does this virtual machine belong to. So in this case, so we can just write like that: name equals web server, owner equals Rob, or application owner equals Steve. and backup team is maybe Mary, and the business unit is payroll. So after creating like tons of virtual machines and different kinds of resources, you can definitely pull up a report and say how many of these virtual machines belong to an owner called Rob, and how many of these resources belong to business unit called payroll, so you can then charge them back. Now I click on next, and this will take a minute to run through the validation just to check if everything is running properly or not. And yeah, validation is passed. Now that's a green signal. Let's just click on create. This will take about 4 to 7 minutes to create a virtual machine. That is the shortest time possible to create a virtual machine, because on premise it used to take months to procure, provision, go through the processes, get the financial approvals to create a virtual machine, or even a physical machine for that matter. But here it's so quick. Now apart from processes, technically creating a virtual machine does not take more than 4 to 7 minutes in this case. You'll be able to RDP once the machine is created. In the next video, I'm going to show you how will you RDP to this virtual machine or remotely connect to this virtual machine. Looks like the virtual machine is completed. The whole virtual machine deployment is created in the resource group, and the resource group name here is payroll. Along with the virtual machine, there were several other deployments here. For example, the storage account was created, the network IP address, which is a public IP, got created, the virtual network got created, and every other thing that you see in this list, one after another. You can find out what exactly happened during its creation by clicking on the operation details button here. Now if I click on resource group called as payroll, I will then be able to see all the resources that exist in this resource group. Let's go ahead and see how we can connect to the virtual machine that we just created. To log on to the virtual machine, I will go ahead and click on virtual machine section right here on the left hand side. Now the list of virtual machines will all be visible in this section, but at this time I have just one virtual machine. The name of the virtual machine is VM Web 01, and the public IP that I would like to connect to it is 23.101.139. This is truncated, so let's just expand like that. 227. This is created in a region called East US. Now I want to connect to it. I will launch the RDP section, so all I have to do is hit the Windows key and R button, and you'll get this pop-up right here. I'm going to type MSTSC, which stands for Microsoft Terminal Service Console. Hit enter, and there you're going to type this IP address, which is 23.101.139.27. Click connect. Now within some time it should pop up for credentials. Now if you get this kind of screen where it is requesting for user ID and password, that means the network configuration is correct. That also means that you have opened the right set of ports on the security groups. The username, remember, it was root admin and not administrator, and the password, don't forget it, and then click on yes. It will take like a couple of seconds to get connected to the virtual machine, load up your profile, and then you are all set to operate on this virtual machine. Traditionally, if you had to create this kind of virtual machine, it will take like several hours to get this established, coordination with the virtualization team communicates with the storage team, and that will take a lot of time just coordinating to create a virtual machine. Right now, here I've got this VM ready. All you got to do is now install the applications and make it production ready. In the next video, let's go ahead and learn how to make it as a web server and how to launch your own web application on this web server. So here's our virtual machine ready to become a web server. To make it as a web server, you need to install the web server component, which we call it as IIS on the Windows machine. If it was Linux, we would have installed probably a Tomcat or Apache on the machine to make it a web server. But this is a Windows machine. So to make it as a web server, you got to click on this little box, which is called as a server manager. And it launches that, and then I need to add certain roles to it, right? And those roles are called as Active Directory roles if you want to make it a domain controller. If you want to make it a DNS server, you will install a DNS role. Want to make it a DHCP server, you will install a DHCP role. But in this case, I want to make it as a web server so that I can host my web application on top of it. So I have to make it as a web server. So I'll click on this, and then as always, you get this wizard. So I'm going to click next. If you're looking at this screen for the first time, I would suggest you to read these little statements here. They're quite informative. Click next. Installation type, do you want it to be a role-based or feature-based? Remote desktop server installation. Now, I want to make this web server a virtual machine, so I'll go for the first one and not a remote desktop one. Click next. Server selection, yes, that's the server, which is going to be a web server. Click next. This is the set of roles that I was talking about. Now, I want to make it a web server, so I'll scroll down till the point I see web server IIS. I'll just put a checkbox there. And this pop-up that you get is this set of dependencies which are required for this server to become a web server. Add features, and then click next. Click next again. This is just a set of dependencies, and like I said earlier, if you're doing this for the first time, spend some time reading these things, what exactly it is doing, right? Click next, next again, and finally click on install. Give it some time for this installation to finish, and then it's ready to become a web server. So looks like this machine has become a web server now, because now it says installation succeeded on my server. I click on close, and also close this server manager screen and launch the Internet Explorer browser to verify if it has really become a web server. Just to verify if I can access the website internally within the machine, so it will be a local access. Once that is successful, we can then check if it is accessible from the internet through your mobile phone or any other devices. So I'll just do http://localhost, right? Great. There you go. So you get the default page, which is great. So that means the IIS services are running. The IIS engine is responding to the web request. That's great. I will go ahead and minimize the RDP and see if I can access it from the internet. So go back to my laptop here, launch the browser, and then just type http:// well, localhost will not work. I need to know the public IP address of this machine, which is this. So I'm trying to connect to that machine on the public IP on port number 80, right? HTTP is port number 80. Now it's not going to work. It will just try and try and try forever, but it will not work. Why? Remember that on the security groups, we opened port number 3389 to access RDP, and that's how we could access RDP, but we never opened port number 80, and that's why it's struggling to connect. In the next video, let's go ahead and learn how we can open the security groups on the virtual machine. So this is where we were with the previous video. So we tried to access the web server that we just created, but we failed because the connection timed out. And the problem was that the virtual machine was not listening on port number 80. So now let's go ahead and learn how we can open ports on the virtual machine. Now I'm in the Azure portal. I'll click on the virtual machine here and then scroll down to the section where it says networking. Don't forget to look at the other options as well here, which talks about the public IP address here, the private IP address, the virtual network in which it is in, etc. And there are other metrics that it's going to display for performance purposes. It tells you how well your virtual machine is behaving. CPU utilization, there is network utilization, the disk IOPS, and the disk operations per second. Now the objective here is to modify the security group, so I'm going to click on the networking section, and I will see specific details here. I have opened port number 3389 on this security group, and it is an inbound rule. In the outbound rules, you will have all ports open. You see this NA to the internet. That means everything is allowed out to the internet from the virtual machine because it's an outbound rule. Inbound rules are more restrictive in nature. And that's why I've allowed port number 3389 so you can connect to this virtual machine. Now the objective is to add port number 80, so I'll click on that button and then allow a specific port called port number 80, right? So this will be allowed to any website from any destination on port number 80 on any protocol, whether it's TCP or UDP, and I want to allow this, not deny. And the priority in this case is 310. You can just put any number here, and those rules here will be processed based on this number. So I'll also make it a descriptive name, port number 80, and you can put some description here. Click on add. Now within few seconds it should display port number 80 in this rule set. I have just 4 rules in this rule set in the inbound rule section, and I must be able to see port number 80 as well. There you go. The rule number 310 allows port number 80. So now I'm going to go back to this website and refresh the page. Let's see what happens. There you go. Within a click of a mouse, within a second, I'm able to see the website. In the next video, let's go ahead and learn how do you modify the content of this web page so that you can make it more personal and more customized. Okay, so let's go ahead and make this a customized web server. At this time, I'm logged into the Windows machine that we just created in Microsoft Azure. The objective here is to make this a personalized website. In the last videos, we installed the web service role on this machine, and that's how we were able to get to it. When you install the web service role, you will have certain folders created under C drive and inetpub. Under inetpub, you will have www-root folder. Every time you open the local host, or when somebody tries to access the public IP, they will be connecting to this particular file called as iisstart.html. We can either customize this page or put our own file here and name it as index.html. Open this index.html, and now you are ready to write your HTML content inside this particular file. Now you can write simple text like this. This is a sample web page. Or if you know HTML or how to write HTML, you can definitely write the HTML content right here. I will save this page because I don't want to complicate things by writing HTML code, but if you know HTML, please feel free to do so. I will close it. And if you notice, this page does not appear to be an HTML. This is still a notepad. You see this? There's a difference here. It's a text document, and this is an HTML document. So although the extension here appears to be .html, it is not an HTML document. That is because the extensions are hidden. What does that mean? Let's go ahead and see this. If I click on View and then click on this file name extensions, check this. You will notice that index.html is not index.html. Instead, it is index.html.txt. So I will right click and rename this and remove the last 4 characters. And that will make it an HTML document. Now it has got its own icon as well. Let's go ahead and refresh this page in the background. I'll hit F5 on the keyboard. And as you see, the local host is now pointing it to the new file that we just created. What will happen if I do the same thing on my local laptop? So I will minimize this server and then go back to this little screen and then refresh the page. Now instead of going to the default IIS page, it should take me to the new file that I got created. There you go. Just by refreshing it, it is taking me to the new file. So every time you create a website, by default, it points it to the index.html. So even if I do index.html like this, it will be taking me to the same file. So in this video series on virtual machines, you learned about how do you create a virtual machine in Azure, how do you make it a web server, and how do you access the web server from the internet and from the intranet. Then we learned how to customize the web page. Traditionally, if you had to install applications, then the first thing that we had to do is to create either a virtual machine or a physical machine. Once the machine is ready, you will then have the dependencies installed, and then the application sits on top of the dependencies. So we are here creating multiple layers, starting from the application, dependencies, then the operating system, and finally the hardware which it talks to. Now containers and virtual machines have a similar resource isolation and allocation benefits, but they function a little bit differently because containers will virtualize the operating system. The virtual machines will virtualize the hardware. Containers are more portable and efficient. Now, as you see in the picture here, there is a container managing application like Docker, which can manage multiple containers. Each container will then host application and its dependencies. As you see in the picture, application 1, 2, 3 have different set of dependencies or binaries or libraries, but still they are sitting on the same virtual machine. They are isolated with the help of containers. The green, orange, and red boxes on the right-hand side are containers, whereas on the left-hand side, the same colors represent virtual machines. The one on the right side is a containers architecture, where we have multiple containers sitting on the same virtual machine. Although they are in the same virtual machine, they are still isolated. The dependencies is the one which the container handles. In this case, or in this example, it is the container managing application like a Docker engine, which will let the communication happen between the container and the hardware infrastructure. Containers and virtual machines used together provide a great deal of flexibility in deploying and managing the applications. So, containers are an abstraction at the application layer that will package the code and dependencies all together. Multiple containers can run on the same machine and share the operating system kernel with other containers. Containers take less space than virtual machine, whereas virtual machines are abstraction layers on the physical hardware, which can turn on server into many servers. The hypervisor will allow multiple virtual machines to run on a single machine. Each virtual machine includes a full copy of the operating system, the application, necessary binaries and libraries, which will take tens and hundreds of gigabytes together. Virtual machines can also be slow to boot. But if you look at containers, containers are very quick. They can handle several applications and require very less virtual machines and few operating systems. So containers and virtual machines have similar resource isolation but function differently because containers virtualize the operating system instead of virtualizing the hardware. Containers are portable, efficient, and very quick in running the application. So Docker. So container is a standard unit of software that will package your entire application code and its dependencies so that the application can run quickly and reliably on that virtual machine.
Let's learn to create, configure, and deploy a Docker container to Azure container instances in Azure portal. The container is created from an image template called as Microsoft Hello World. The image package is nothing but a small web application written in Node.js and serves as a static HTML page. Let's get started with creation of containers in container instances. Log on to your Azure portal and search for containers in the search box. You will find container instances as one of the first ones being populated there. Click on it and you will be prompted to create a container instance. You can click on Create Container Instances or click on this plus Add button. Once you click on it, you will see a screen that will prompt you to fill up several fields here, starting from resource group, container name, region, image type, image name, operating system, and size. Let's go ahead and fill this up one by one, starting with the resource group. As we know, resource group is a grouping of resources. So over a period of time, when you create resources, you will know how many of the resources have been created in the resource group. So you can charge them back or also use for troubleshooting purposes. I do not have a resource group at this time, so I'll go ahead and create a new one. Call it as a business unit called as payroll and say OK. Container name, you can choose to give any container name. In this case, I'll say my web instance. Select a region. Image type is pointing where your image is actually hosted. Is it somewhere out on the public or on a private internal repository? Also then select the image name. In this case, I'm selecting the image name as Microsoft/ACI-Hello World. OS type, do you want a Linux container or a Windows container? And depending on the compute power, and the memory you need for that container, you may want to pick and choose a size. I will leave it as 1 CPU and 1.5 gigs of memory at this time. Click Next to select the ports. By default, you will see port number 80, but in production environments, we'll select port number 443 as well, so that you can have HTTP traffic going over SSL. And because this is a public instance, I would like to have a public IP address associated to that. Also make sure that you have a DNS name label typed in, because this is what we'll use to access the web application in the container. In this case, I'll select my web instance. Click Next and configure the restart policies. Configure these additional container properties and variables. What is a restart policy? Docker provides restart policies to control whether your containers start automatically when they exit or when Docker restarts. Restart policies ensure that linked containers are started in correct order. Docker recommends that you use restart policies and avoid using process managers to start containers. In this case, you can have the restart policies as on failure, always, or never. I will leave it to default at this time. You can also have the environment variables set up here. For example, the path environment variable, which is very important because every binary looks at the path environment variables. In Windows environment, you also have the temp environment variable, which will take you to the temporary folders. So if your application demands a specific environment variable to be typed in, you may want to look at the product documentation and type those specific environment variables. Command override is an option where you can go ahead and type in a bash script as an input, which will be acting as a startup script. I will leave these values empty and default at this time and click Next. Tags will help me create a CMDB, a configuration management database. So over a period of time, when you accumulate resources in your resource group, you will know how many of these resources are owned by a person called as Rob. Let's start filling up these values one by one so you understand better. In this case, I will type the tag as name and call it as web application. Owner is Rob at thecompany.com, and then the business unit is payroll. So what happens with this? At the end of the month, you will know how many of the resources have been created for a business unit called payroll, or how many of these resources are managed by the owner called as Rob. So you can pull up a report later on and then identify them. I'll click on Next, Review and Create. Now what I will see is all the options that I've selected so far. If you are not satisfied with these options, you can go ahead and click on Previous and modify these values. Looks like the validation has passed, and I'll click on Create at this time. It will take a minute or two to create a container instance. Looks like the deployment is complete. Let's click on Go to Resource. If you look at the properties of the web instance, you will see that the FQDN of the web application is my web instance dot the region where the container is hosted .azurecontainer.io. You can access this web application by just copying this and pasting it in a browser. I'll be launching the incognito mode to make sure that my cookies are not being used. So I'll hit Ctrl+Shift+N on the keyboard as I'm using Google Chrome. Just type that and hit enter. There you go. So you now have your first web application hosted on containers. Networking is backbone and essential component of any infrastructure, and this is no different for the infrastructure in the cloud. Networking on Azure allows you to connect cloud resources with each other and also with other on-premise infrastructures. Azure networking, which is also called as VNet, which stands for Virtual Networks. Now, virtual networks will let you provide isolation, segmentation of networks, and communication between VNets and communication with other on-premise resources. You can filter the traffic based on what you want to allow in the Azure networks. In one of the labs done earlier, you might have noticed me filtering port number 80 for all web traffic. This is done through security groups. That means that the security groups are acting as firewalls to restrict and allow the traffic that you want to whitelist and blacklist. In the next video, let's go ahead and create a virtual network and host a virtual machine in that virtual network. We'll also create a second virtual machine in the same virtual network and allow communications between these two virtual machines. By doing so, you will understand the importance of virtual networks and security groups, and you will also know how to do hands-on for creating a virtual network with multiple resources. In this lab, we will go ahead and create a virtual network in Azure subscription. In the virtual network, we will create two subnets, and thereafter, in each subnet, we will be hosting two virtual machines. The communication between each of the virtual machines will then be established with security groups. Let's get started. I am currently logged into my subscription, and I'm using a pay-as-you-go subscription, but if you are doing the labs along with me, you may have to create a free tier account for yourself. To create a virtual network, I will click on Virtual Networks right here, and then this will navigate to me a section where I can create virtual networks. I can either click on the Add button or Create Virtual Network, and this will take me to a blade where I have to fill up the options like the name of the virtual network, address space, subscription, etc. I'll quickly fill these up. The name of the production as vnet_production. I can use a class C or class B or class A address space. Make sure that you research on what is RFC 1918. Basically, it states that IP addresses are classified as class A, B, C, D, and E, and it also talks about private addresses and public addresses. I will use a class C address /16, which will give me about 65,000 IP addresses, which is a very big range. You can choose a subscription as pay-as-you-go, or if you're using a free subscription, you will see free trial in this drop-down menu. Make sure you have a resource group. I will create a new resource group as I do not have it. Say payroll and say OK. Select a region and then a subnet name as well. Just call it as subnet 1, and the address space must be within this address space and not outside it. So I'll select 192.168.30.0/24. I'll leave the rest of the default settings and click on create. It will take a minute to fully create a virtual network in Azure. Now that my virtual network vnet_production is ready, I'll click on it and then create another subnet. When we were creating the virtual network, we created a single subnet. But then to create another subnet, you have to click on the subnet section and then click on the plus subnet button. As you notice, there is a subnet 1 which is already available because this was created during the VNet creation. I will click on this button to create a second subnet. I'll call this as subnet 2, and the CIDR block will be 192.168.40.0/24. I'll leave the rest of the options default and click on OK. It will take a minute to create the second subnet in the existing virtual network. Now that the subnet is created, we are now ready to host virtual machines in each of the subnets. So when we are creating virtual machines, we must make sure that we are pointing it to the following vnet_production virtual network, and then in each of the subnets we will be hosting virtual machine each. Let's go ahead and create virtual machines. To create a virtual machine, I need to click on this virtual machine option on the left hand side and then click on this add button. This will give me a blade or a form that will let me fill up the options like the virtual machine name, the resource group, etc. Let's start by selecting the resource group. We already have a resource group with the name payroll, so I'll select that. The virtual machine name, let's call it as web server 1.
and then we'll select the region. So I need to select the same region where I have the virtual network, which is the central US. At this time, I do not need any redundancy. I'll leave the image as Windows Server 2012 Data Center. Okay, 2 CPUs and 8 gigs is actually a lot for our test environment. So let's go ahead and change the size. I'll change the size to not the lowest available because I'm looking at performance as well. I think 2 CPUs and 4 GB of RAM is good for now. I'll select the username as admin and make sure that I will give it a strong password. So looks like my characters are accepted. Inbound ports, I need to have 3389 allowed because this is a Windows based machine. I need to do RDP to this machine, so I will have port number 3389 or RDP selected. If I would have selected Linux machine here in the drop down menu, then I had to select SSH because Windows does not listen on 22 and Linux doesn't listen on 3389, right? So you need to select appropriate ports. Yeah, I do not have a Windows license, so I'll select no. Choose the hard disks carefully here because by default it points to premium SSD, which is of course going to give you a lot of performance, but then also is expensive. So I will choose a standard hard disk in this case because I'm not looking for great performance, but anything that lets me do this lab is fair enough, and standard HDD is good for that. I'll select next to select the networking options. Remember, we created a virtual network few minutes ago, so I will select VNet_production because this is the only network available in our region. We created 2 subnets. So we have subnet 1 and subnet 2 in the drop down menu. This is web server 1 and hence I will select subnet 1. When we create web server 2, I will be selecting subnet 2 in the drop down menu. I will leave these options as default because that's what I want. I wanted to have a public IP address so that I can RDP from my network. I also want inbound ports to be RDP so that it will allow incoming connections on 3389. I'm not doing a load balancer lab at this time, so I'll select no, click next on the management section, and I will leave rest of the options as default. I'll leave the rest of the options as default. Under the management section, I will leave these options as default and click on advanced. All these options are also something that I do not want at this time, so next and then create. It will review the settings, look at all the settings one after another, and then make sure that it validates and checks to see if these settings and parameters are right. And if everything is correct, it will say validation has passed. I'll click on create. My virtual machine deployment is underway, it's in progress, and it will take like 4 to 7 minutes to create Windows-based virtual machines. For Linux machines, it is very quick and not more than 2 minutes for a regular Ubuntu or a CentOS virtual machine. So once the VM is created, we will RDP to it, connect to it, and then we'll progress with creating a second virtual machine. Okay, looks like our virtual machine deployment is complete. I'll click on Go to Resource to go to the virtual machine and then capture its public IP. On the right hand side, I'll see the public IP address of the virtual machine. I'll copy this and then go to the MSTSC or Microsoft Terminal Services console. There, I can copy and paste the public IP address and then click on Connect. This should prompt me to type the user ID and password. Should not take more than a minute to get connected and show us the desktop. So our Windows Server 2012 R2 machine is ready. Let's go ahead and create another virtual machine, Web Server 2, in the second subnet, which is subnet 2 in the same VNet, which is VNet-production. To do so, I'll minimize this RDP and go to the virtual machines, and I will follow the same exact procedure to create a second web server. The resource group will be same. The name of the virtual machine will be Web Server 2.
make sure we select the same region and select a Windows machine here. Change the size to something acceptable, which is 2 CPUs and 4 gigs of memory. Type the username and confirm the password. And I'll make sure that I'm allowing RDP here. I'll leave rest of the options as default. And let's click on next. I have to wait in the networking section to make sure that the virtual network selected is right and the subnet selected is subnet 2. I'll just click on next, leave these options as default and quickly create the second web server 2. We'll again run through the validation. Once the validation is complete, click on create. I'll now pause the video and start again once the virtual machine deployment is completed. The virtual machine is now created. I'll click on go to resource to go to the virtual machine. And just like what we did previous time, I'll launch the MSTSC, which is also called as Microsoft Terminal Services Console or the remote desktop connection. I'll copy its IP address and paste it here so that that will take me to this new web server that we just created. Should be quick to connect to the second virtual machine because we have given enough CPUs and memories to it, and there is no application running on it, so there is no overhead on the virtual machine, so performance must be good. So now what we have is a set of 2 virtual machines running on 2 different subnets in the same VNet. The objective is to connect these 2 virtual machines and make sure that they are reachable. The first thing that we have to do is open the firewalls on the virtual machines, so at least we can have some kind of connectivity there. Right now these 2 virtual machines are totally isolated. Now that both the virtual machines are created and we were also able to RDP to this virtual machines, I will go ahead and keep them side by side so that we can test and verify the connectivity. So this on the left hand side is my web server 1 and this is web server 2. Just type hostname to verify. Yeah, this is web server 1 and this is web server 2. I can just type ipconfig on each of these machines to identify their IP addresses. So if you notice, their IP addresses are in this range, which is 192.168.30. This was the CIDR block of the subnet 1 and hence it got an IP address in that range. If you look at the second virtual machine, you will see the IP address in the range of what's assigned to subnet 2, which is 192.168.40.4. Let's see if we can ping these 2 virtual machines. Say ping 192.168.webserver2's IP address, which is 192.168.40.4. Yes, we are able to ping it. Let's also try to do it from the second machine, which is 192.168.30.4 from here. .30.4. Enter. So that means that the communication is well established between these 2 virtual machines. Let's see how this is happening. Now I'm going to go back to the Azure console and look at the networking section. In the networking section, although we have explicitly opened only 3389 from anywhere, look at the second rule, which says allow VNet inbound on any port, on any protocol from any virtual network. So communication between the virtual machines is already there. It's there by default. Okay. So you can click on this particular network security group and see what the default options are. I'm going to click on inbound security rules. And the first one, as we know, is the one that we created, but the rest of them are default. If you click on this little icon here which says default rules, it will not show you the default rules. So this one is explicitly created. But if I click on this default rule option, it will show me what the default rules are. That means by default, the virtual machines will be able to talk to each other just because of this rule. At times, even after having this particular rule in place, the virtual machines may not be able to talk to each other because Windows has an inbuilt firewall. So you may have to allow a rule on the inbuilt Windows firewall, or specifically for ping connections, you have to allow ICMP. In this lab, we created a virtual network with 2 subnets, and then we created 2 virtual machines in each subnet. We also saw how the communication happens between the 2 web servers, or we can say any resources. So even if we would have created a database in the second subnet, the communication will happen based on the rules in the security group. Security group act just like the firewall on your premise, so you can allow inbound connections or outbound connections in the security groups. When you create web applications, you need to ensure that the users get 100% uptime for the web applications they are accessing. This cannot be achieved with a single web server, because if that web server is down for maintenance purposes, patching, or for any other reason, then the end users will have difficulty accessing the application hosted on the web server. For redundancy purposes, organizations would create multiple web servers and put them behind a load balancer. The load balancer absorbs the traffic and evenly distributes the traffic originating from various regions to the web servers hosted in your data center. Azure provides this service with a service offering called Azure Load Balancer. The Azure Load Balancer ensures that the applications hosted on your data center are highly available. The Azure Load Balancer can be used for traffic originating from the internet and also for the intranet-based applications. So the purpose of the load balancer is to distribute the traffic to the virtual machines configured in the backend pool created in Azure Console. The term gateway is used for a device that connects 2 networks. Azure provides means to connect 2 networks with the help of a virtual device called as a VPN gateway. This device can be used to connect 2 virtual networks in Azure or connect virtual networks with your on-premise data centers. VPNs usually encrypt the network traffic, and in this case, the VPN gateway is used to send encrypted traffic between an Azure virtual network and an on-premise location over the public internet. For the exam purposes, remember that the VPN gateway can be used to connect the virtual networks in Azure even though they are in different subscriptions, or they can be used to connect the virtual network in Azure with the networks located in your premise or in your data centers. In one of the previous videos, we learned about providing availability to the web application. This was when we were talking about the load balancer topic. But the load balancer does not provide any kind of security. That is when Azure Application Gateway comes into rescue. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web application. The load balancers are operating at layer 4 of the OSI, whereas the Azure Application Gateway is operating at the layer 7. With application gateways, you can make a lot more decisions than just pointing it with an IP address. You can make routing decisions based on additional attributes such as HTTP requests or host headers. You can route the traffic based on incoming URL. So if the traffic is going to /images section, it will go to a particular pool of web servers. If the traffic needs /video folder in your web application, it will go to a secondary set of video-based server pools. This type of routing is an application layer load balancing, which is done at the layer 7. Application gateways can do URL-based routing and a lot more. The application gateways support SSL termination at the gateway, after which the traffic is typically flowing unencrypted to the backend servers. That means all the traffic flowing till the application gateway is encrypted. The certificate is terminated at the application gateway, and then the remainder of the traffic will flow unencrypted to the backend servers. The application gateway will support auto-scaling, zone redundancy, static IP addresses, and also acts as a web application firewall. Remember, that both application gateway and load balancers will act as load balancers, but Azure Application Gateway provides you far more options as far as security, resiliency, and routing based on additional attributes is what Azure Application Gateway can provide. Please read the important features of Azure Application Gateway. Sometimes the web server where the web application is hosted may be too far for the users. And this may happen if the servers are in one geographical region and the users in another part of the world. In this case, the users may complain about latency and low performance of your web applications. This situation is handled by placing content servers around the world, which would cache the frequently accessed content for the users. The users can then access the content from their local region instead of connecting to the source server. This would clearly minimize the latency. This concept is achieved with the help of content delivery networks. Typical usage scenarios include web applications containing multimedia content, a product launch event in a particular region, or any event where you expect a high bandwidth requirement in a region. In today's world, users' experience is everything. Azure Content Delivery Networks lets you reduce load times, saves your bandwidth, and speeds up responsiveness. So whether you are developing or managing websites or mobile applications or encoding and distributing streaming media, gaming software, firmware updates, or even IoT endpoints, you would need content delivery networks to give best performance to your end users.
Organizations use storage on servers and on external storage devices like SAN, NAS, and DAS for various purposes. At times you will host databases like Microsoft SQL or NoSQL like DocumentDB or Cosmos DB. Organizations also keep documents like invoices and other documents and videos on such storage devices. How about backups and long-term retention data? In the next set of videos, we'll learn about Azure Storage Services and how Azure will help us facilitate different kinds of data like structured data, semi-structured data, unstructured data, and archival data. Any kind of data that has a defined length and a format is called as structured data. Such examples are dates, numbers, names. These are the ones that fall into the criteria of structured data and are usually stored in a database. Structured data has a schema so that all the data in the database has certain fields and properties. Structured data can be stored in a database with rows and columns inside a table. Structured data relies on keys to indicate how one row in a table relates to the data in another row of another table. Structured data is also referred to as relational data. So whenever you think of structured data, think about databases like Microsoft SQL, Oracle, Postgres, or MySQL. All the data follows a certain format. The data inside the database can be the sensors data, financial data, could be web data, point of sale data, or gaming related data, or anything that has been manually input using certain forms. Structured data is comprised of clearly defined data types whose patterns make them easily searchable. Structured data is organized and is stored in a relational format, and they fit neatly in tables, rows, and columns. Now that we understand this, let's talk about semi-structured data. Semi-structured data maintains internal tags and markings that identify separate data elements that will enable information grouping and hierarchies. Now, if that is difficult to understand, think about XML files and JSON files. Emails are very common examples of semi-structured data type. At times, Semi-structured data uses NoSQL to store the accumulated data sent through JSON and XML files.
What is unstructured data? Unstructured data is the most common type of data that we play around with every day. For example, the text files, the email messages, PowerPoint presentations, survey responses, transcripts of call center interactions, the posts from blogs and social media, any kind of images, audio files, video files, all of these are categorized as unstructured data. Machine data is another category, and that is growing very quickly in these organizations. For example, log file from websites, server, networks, applications, particularly the mobile data that have lots of activity and performance data going on. Companies are increasingly capturing and analyzing data from sensors on manufacturing equipment and also from IoT connected devices. Such data is unstructured data type. So when you think about unstructured data type, think about the PDF files, the video content, images, etc. that's been stored on your disks.
Azure Database Services. Azure Database Services are fully managed platform as a service database services. When you hear this term fully managed, it means that most of the components of the underlying infrastructure are managed by your cloud provider. In this case, it is Microsoft. So they will be managing the hardware, the operating system, the patching of the operating system, and patching of the firmware as well. You do not have to worry about the underlying virtualization model. All you have to care about is just the data that stores inside the database and the applications that connect to it. Microsoft Azure provides database services in various forms for various purposes. The developers should take advantage of these database services because they provide automatic monitoring, threat detection, and also improved performance. Some of the data service types in Azure are Cosmos DB and Azure SQL Database. So the former one is a NoSQL and the second one is a relational database. If you have on-premise infrastructure, you might want to take advantage of Azure migration services in the form of Azure Database Migration. This is also a fully managed service designed to enable seamless migrations from multiple databases to Azure data platforms. This makes sure that there is minimal downtime. In the next set of videos, let's go ahead and see how you can create an SQL database in Azure platforms. Let's go ahead and create an Azure SQL database. I'm currently logged into the Azure portal and clicked on this Azure SQL database section. You can either click on the add button or this blue little button which says create SQL database. Just like any other resource or service, you will also get a form to fill out, and this is usually called as a blade. We will go through each one of these settings to create the SQL database. The first option is to select a subscription. I have pay-as-you-go subscription. You may want to choose a free tier or an enterprise one depending on the one that you're using. I may have to create a new resource group. Although I have few resource groups here, I don't want to use them. I want to create a new one. So I'll say new, and this is for a business unit called as human resources. Say OK. The database name is employee information. I may also want to give a server name here. Create a new server, enterprise information, something like that. And I'm allowed to choose only lowercase letters. That's good. Type in a username and password. Okay. And then you may want to select it in a region which is very close to your applications. Usually this region for the database must be close to where your applications are sitting. So let's just go ahead and select West Europe, or if you can't see that in the drop down menu, you also have an option to just type something like that, West Europe. Okay, and say alright. We'll take a few seconds to get that sorted.
The next option is to select an SQL pool. When would you select this? Yes or no? I will choose Elastic Pool when you have unpredictable demands on your SQL workload. So if this is really going to be in production environment, when you have unpredictable workloads and you're expecting the traffic to hit your database and the latency is expected to be in milliseconds, then I want to select Elastic Pool. At this time, it's just a test case, so I'll say no. By default, the compute and storage is Gen 5, 2V cores, 32 gigs storage. Is this really required for the test environment? And even to start off in your proof of concepts in your enterprise, you may not need compute and storage to be so high. Now, I'll click on Configure Database. Depending on how much of a resource you want to allocate to the database, you may want to pick and choose one of these. This compute generation Gen 4 is giving me 24 V cores. Gen 5 is giving me 80 V cores with 408 gigs of memory, and this is massive. We really don't want to go this size at this time, but it's always good to know that you have a heavy duty server sitting in Azure data center ready to give you the resources that you want. Okay. You can also go for a basic one, which is for less demanding workloads, and then move this slider left or right to increase or decrease the maximum data size, right? There are other sliders here like standard, premium for intensive workloads. It is always good to know these options, but at this time, I'll just stick to basic and apply. So this will give me just 2 gigs of storage. Fair enough for a test environment. Click on next for additional settings. Microsoft gives us the option to start with a blank database or restore from a database or select sample data to populate a new database. So if you would like to just test and look around things, it's good to have a sample database with us so you can run certain select queries on the database, right? So this will pull up a sample AdventureWorks database so you can just run some CRUD operations like create, read, update, and delete operations on the database just to play around, okay? Database collation is left to SQL Latin 1, General CP1, CI, AS, and of course cannot be altered now and later on as well. Do you want to have advanced data security? Do you want to protect your data against innate threats? Do you want to have vulnerability assessment? Do you want to have data classification done on your database? So these are certain things that you get with advanced data security. Yes or no? You may want to start it right now or with just a free trial because you get a 30-day free trial with this. At this time, I'll just say no and click on next. Tags. I'll apply some tags here. Name, and the value is SQL database. The owner is, let's say, rob@company.com. Yeah, and the DB administrator is steve@company.com. Yeah, so this is very important. Tagging is very important. So later on, you can pull up certain reports as to how many of these resources in my resource groups are owned by Rob. So you can just contact him for monthly patching purposes or maintenance purposes, etc. Finally, review and create. It will do some validation, will take a minute, and then just go ahead and create it. You should be able to see the new database under the SQL database section. I will pause this video for a minute and we'll restart once the database is created. Okay, the database is created. Let's go ahead and click on Go to Resource. Now, there are a lot of options out here on the left hand side. Our database name is Employee Information. It is created in Western Europe, and here are the tags. And as we scroll down, you should be able to see different parameters of performance like compute utilization, database storage, security information like TDE, advanced data security, automatic tuning. So it's like one snapshot, a dashboard for your entire SQL. And then you can go ahead and click on Configure to change certain settings. Remember this screen where we were checking the compute power of the SQL server behind the scenes. You can change it later on as well. You can change it while the database is running. You can change it from basic to standard to premium and other compute purchasing options we have right here. There are lots of other options like geo-replication. Do you want it to replicate it to a different data center, connection string, synchronizing to other databases? So Microsoft SQL on Azure platform gives us all the options that your on-premise databases has. You can copy, restore, export, change the firewall settings so just the applications that need to connect to your database can connect. So if I click on this firewall setting, it will give me an option to add the IP address here. Let's click on add client IP and save it. And that means that the incoming connections will be allowed only from 46.95.212.9. You can also have incoming connections allowed from a particular virtual network or create a virtual network from here. As you might have noticed, you have all the options that you actually need to manage your SQL database at an enterprise scale. Now this is a sample database. That means you have certain data inside this database and you can query that using a query editor. Once I click on it, I just have to type my credentials and click on OK. Now you get into the query analyzer section where you can type all your queries here, right? You can expand the table section to see what tables you have and then start querying the tables like this. Select start from dbo.build version, let's say. Right, that's my table name I picked up from here. If I run it, it's going to show all the data that I have inside that particular table. I may want to change it by changing the table name here, saleslt.product model, and then run it. It will show me all the data that I have inside this table. As you see, the information picked up is very quick. It's giving me information with least latency. See, it took about 0 seconds. So you are getting the IOPS in about milliseconds to retrieve this information. It's very fast and secure as well. This database in Microsoft SQL can be scaled to enterprise scales because you can configure it later on as well to change the CPU and increase the performance thereafter. Microsoft Azure Cloud Platform provides us with compute services with virtual machines, database services with Azure Database Services, and then you can also host applications in web apps. But Microsoft Azure really wants to make use of the services provided by their partners, independent software vendors, and startups because they have a lot more to offer. Now these services are optimized to run on Azure, and Azure Marketplace allows customers, mostly IT professionals and cloud developers, to find solutions, try and purchase them from the marketplace. Now these solutions that are provided in the marketplace are certified to run on Azure. Microsoft Azure Marketplace catalog spans several industry categories, including, but it's not limited to, open source platforms, virtual machine images, databases, application build, and deployment softwares. You can also find security related services like threat detection and blockchain services. Azure Marketplace can help you provision end-to-end solutions quickly and reliably hosted on your own Azure environment, so you do not have to make everything from scratch. At this time of recording, there are over 8,000 listings in the Azure Marketplace. You can find more about Azure Marketplace at azuremarketplace.microsoft.com.
The Internet of Things is becoming an increasingly growing topic of conversation. It is a concept that not only has the potential to impact how we live, but also how we work. But what exactly is Internet of Things? What impact is it going to have on you? Well, broadband internet is becoming more widely available. The cost of connecting is decreasing. There are more devices being created with Wi-Fi capabilities and sensors that are built into them. Technology costs are going down. The smartphone penetration is skyrocketing. And all of these are creating a perfect storm for the IoT. This is the concept of basically connecting any device with an on and off switch to the internet. This includes everything from cell phones to coffee makers to washing machines to headphones, lamps, wearable devices, and almost everything else that you can think of. Can you imagine the amount of data that tiny sensors would be creating? Can you imagine when these sensors and devices go at an enterprise scale,
how much processing and internet bandwidth is required. There are a number of services that can assist and drive end-to-end solutions for IoT on Azure. Two of the core Azure IoT service types are IoT Central and Azure IoT Hub. In the upcoming videos, we'll understand what is IoT Central and what is Azure IoT Hub, and also possibly do some demonstrations of them. Azure IoT Hub is a managed service which is hosted in the cloud. Now, this acts as a central message hub for bidirectional communication between your IoT application and the devices it manages. You can use Azure IoT Hub to build IoT solutions with reliable and secure communication between multiple millions of IoT devices. You can connect virtually any device to your IoT Hub. IoT Hub supports communication from the device to the cloud and from cloud to the device. That means it will support multiple message patterns, file uploads, and reply request methods to control your devices. IoT Hub monitoring will help you maintain the health of your solution by tracking events such as device creation, device failures, and device connections. IoT Hub has the capability to connect to multiple IoT devices. So you can manage industrial equipment such as manufacturing, tracking valuable assets in healthcare, and monitoring office building usage. In the next demonstration, we'll see how you can add an IoT device to Azure IoT Hub. To do so, we'll be simulating a device called as Raspberry Pi so that it can then send signals to the cloud-based IoT Hub. At this time, I'm logged into my Azure portal. Now I've just searched here with this term called as IoT, and I get this two options called IoT Central Applications and IoT Hub. I just clicked on this IoT Hub and landed in this place where I can either click on this Add button or this blue button called Create IoT Hub. Now when you click on this, it will take you to another blade where you got to fill up these options one by one. So the objective is to create an IoT hub so that other devices like Raspberry Pi, Node MCU devices, or other kinds of IoT devices can then get connected to this particular hub. Once the devices get connected, you will have the ability to monitor those devices using IoT Hub. The subscription is pay as you go. I'll go ahead and create a new resource group called Developers. Click on OK. I'll select West US region, just leave it the way it is, and then give it a name that is unique to my IoT hub. Call it as IoT Hub in US West. Probably this is unique, okay? And then you can size and scale depending on the number of devices you may want to configure. You will choose the pricing and scale tier from this. It's always good to look at the updated documentation by clicking on this hyperlink. Depending on the number of devices you want, depending on the number of messages, message routing, IoT edge, and the monitoring you need, you may want to pick and choose a particular scale tier. At this time, this is just a basic environment, hence I will select a F1 free tier environment. With that, I'm going to get 8,000 messages per day. That means my devices and cloud can send back and forth 8,000 messages together. With that, I'm not going to paying anything. It's just 0.00. I have got these following features along with F1 free tier. Next, if you're happy with this, just click on Review and Create. It will validate these options and then let that IoT Hub get created for you. It should not take more than 3 minutes to get this created. It's pretty quick. I'll pause this video for a minute, and once this is ready, we'll get started again. Okay, so now that it is ready, I'll click on Go to Resource. And it looks like I've got the IoT Hub in US West created. Absolutely healthy and fine. And now the objective is to add an IoT device. To add an IoT device, you've got to scroll down to the bottom and then click on IoT Devices and then click on New. Alright, so you can just give any name here. Let's say Raspberry Pi. But if it is your watch, clock, refrigerator, washing machine, anything that is IoT enabled, if you'd like to give a particular name to it, you can do so. Alright, I'll leave these options and I'll explain what these are later on. And I'll click on Save. Now this is saved and ready, so I can have a real physical Raspberry Pi device connected and let the sensors send the data to Raspberry Pi device. If I click on it, you will have the options to create a connection string between that device and the IoT hub. So I've got this primary key, secondary key, a connection string which you may want to choose and provide it to the Raspberry Pi to make a successful connection. Because I cannot show you a real physical box, I will choose a Raspberry Pi simulator. To do so, all you gotta do is go to Google and type Raspberry Pi simulator. I just typed for Raspberry Pi simulator in Google and got the search results. The one that I'm interested is the one that is posted in GitHub. So I'll click on it and it will take me to a page with a Raspberry Pi interface. For those who are curious to know what Raspberry Pi is, I would suggest you to go to Amazon.com and then type Raspberry Pi there. Now, that is a real physical device which looks like a microchip and linear integrated circuit that has connections going back and forth to 4 USB ports. It has a very small CPU, but yet powerful yet for the device. It has sensors, it has an HDMI port and several connections that make it a mini computer. Okay, so now that we have a simulator opened up, I'll click on close right here and I have to look for a place where I can have the connection string. Now line number 15 here shows me the connection string. Okay, so all I have to do is get the connection string from the Raspberry Pi IoT hub and paste it here and let this run. Now just to give you a brief overview of this little box here is a Raspberry Pi. Like I was saying, it has 4 USB ports, 2 here and 2 here. This is a Ethernet port where you can connect your RJ45 connector. This is an audio out connector. And this little white strip is where you can connect a camera, like you see here closely. Notice it's written camera right here. This is an HDMI port which you can connect to your external HDMI compatible monitor or a TV. This is a power supply, and this is where you can connect your MMC card for the operating system. There are a couple of pins here which will be called as general purpose input output pins, which can be connected to different kinds of sensors. Now here for lab purposes they have used something called as a breadboard here. This white box is called as a breadboard, and you are connecting the breadboard to a sensor here, specifically a temperature sensor. And as soon as the signal is sent out to this sensor, this little LED blinks, and that's what the code here says. So we're trying to determine the temperature and the humidity in their environment. Of course, it's not gonna send you real temperature, but it is just a simulation, hence it is really in a controlled environment. So let's get started. I will go ahead and copy the connection string from the Azure portal and paste it here. Okay, so click on this, and my primary connection string is as follows. So I'll copy that. Okay, I just copied it, and then I will go to the Raspberry Pi simulator and paste it here. Okay, there you go. So that is my connector. The host name is IoT Hub INUS West, and then that's the fully qualified name connecting to the Raspberry Pi, and that is the shared key for authentication purposes. Alright, so let's go click on this little run button, which will simulate certain values and take those values to the cloud. If you notice on the bottom right hand side, it is simulating certain values, 29, 26 in humidity, and every time it generates a number, the LED on the top left hand side blinks, and this code will let you do that. So if you're really interested in this, I would suggest you to go ahead and procure or get a device from Amazon. It's available for cheap. It's like $35, and it also comes with breadboard and sensors as well. So I suggest you to go ahead and look out for a deal on the internet which will give you the whole package to play with those IoT sensors and get that information rolled out to the cloud platform. Okay, so looks like the Raspberry Pi is sending information to the cloud because we have set the connection string to the cloud-based Azure device. Okay, and this is being stored right here. I will stop this simulation and then go to Raspberry Pi here under IoT Hub, and let's see where those values are. Now if I scroll down to the bottom, under monitoring section, you have metrics. If I click on those metrics, you gotta go ahead and generate certain metrics for myself. Now I've been doing on and off with the Raspberry Pi quite a few times just to see the data simulation, data it sends to the Azure portal here, and I could see that there's certain graphs that are generated here. I also played around certain metrics to add and remove the right set of metrics here, and you can see that the values are being generated. It tells us about the total number of messages sent, connected devices, total device data usage patterns, etc. You can of course go ahead and add your own metrics from this button here, and there are a lot of metrics to see for. Now, depending on what your vendor recommends, you may want to pick and choose these metrics from this drop-down menu. The objective was to show you how data can flow from real physical devices to the Azure IoT Hub and how IoT Hub can handle this data. Now, this data can be temperature information, sensors information, or any other information that's being sent from your watches, refrigerators, washing machines, cars, navigation devices, thermal systems, etc. Data comes in all types of forms and formats, and like I always say, it's not one size fits all. When we talk about big data, we are referring to a large, voluminous amount of information. Data that is gathered from weather systems, communication systems, imaging platforms, and many other scenarios that generate large amounts of data. This amount of data becomes increasingly hard to make sense of and make decisions around. The volumes are so large that traditional forms of processing and analysis are no longer appropriate. There are open source cluster technologies that have been developed over a period of time to deal with this large data sets. Microsoft Azure supports a broad range of services and technologies to provide big data and analytical solutions. Some of the most common big data and analytical solutions in Azure are Azure SQL Data Warehouse, HD Insight, and Data Lake Analytics. Let's understand what their purposes are and the differences between them. Azure SQL Data Warehouse is a cloud-based enterprise data warehouse. This uses massive parallel processing, also called as MPP. MPP is used to quickly run complex queries across petabytes of data. You can use SQL Data Warehouse as a key component of a big data solution. You can import big data or massive data loads into SQL Data Warehouse with simple SQL queries. And this can then use the power of MPP to run high-performance analytics. Compared to traditional database systems, analysis queries finish in seconds instead of minutes, or hours instead of days. In cloud data solution, data is ingested into big data stores from a variety of sources. As you see in the image, data is ingested from various sources like IoT, social networking, images, and also from various API calls. Once the data is ingested, it is stored, prepared, and trained using machine learning algorithms, and then served using data warehouse. SQL Data Warehouse stores data into relational tables, and this format significantly reduces the data storage costs and also improves the query performance. There are several open source software utilities like Apache Hadoop, Spark, and Kafka that facilitate using a network of several computers to solve problems involving massive amounts of data and computation. HD Insights will let a business run such open source framework on HD Insight platform. HD Insights is a cost-effective enterprise-grade service for open source analytics. You can effortlessly process massive amounts of data and get all the benefits of the broad open source ecosystem with the global scale of Azure. In addition to this, HD Insights also supports data warehousing, machine learning, and IoT, and integrates seamlessly with other Azure data sources like Data Factory and Data Lake. Azure Data Lake Analytics is an on-demand analytics job service that will simplify big data. Instead of deploying, configuring, and tuning your hardware,
You write queries to transform your data and extract valuable insights out of it. The analytics service can handle jobs of any scale instantly by setting the dial for how much power you need. You only pay for your job when it is running, making it cost effective. The data lake analytics dynamically provisions resources and lets you do analytics on terabytes to petabytes of data. And you pay only for the processing power that is used. So as you increase and decrease the size of the data stored or the amount of computing resources used, you do not have to rewrite the code. Data Lake Analytics deeply integrates with Visual Studio, so you can use your own familiar tools to run, debug, and tune your code. The Data Lake Analytics includes the SQL, which is a query language that extends the familiar, simple, declarative nature of SQL with the expressive power of C#. Data Lake Analytics works with Azure SQL, Azure Warehouse, and other Azure service offering, thereby providing you the highest performance, throughput, and deep integration with other Azure services. When devices learn automatically based on our behaviors, and then they help us perform better and achieve futuristic goals, then that is machine learning. The machines learn based on the data that is accumulated from our behaviors, and that could be purchasing items from a store, traveling plans, sport activities, credit card usage, web browsing, shopping patterns, and this list could just go endless. The data is collected and forecasts or predictions are done based on the data that the machine analyzes. For example, when you shop online, machine learning helps recommend other products you might like based on what you have purchased. Or when your credit card is swiped, machine learning compares the transaction to a database of transactions and helps detect fraud. Probably your robot vacuum cleaner vacuums a room and machine learning helps you decide whether the job is done. Machine learning is an application of artificial intelligence that will provide the systems the ability to automatically learn and improve from experience without being explicitly programmed. The primary aim is to allow the computers learn automatically without any human intervention or assistance, and then adjust its actions accordingly. The process of learning begins with observations, looking for patterns in data, and make better decisions in the future based on the examples that we provide. Microsoft Azure has a machine learning offering in the form of Azure Machine Learning Service and Machine Learning Studio. In the next set of videos, let's understand what these two are. Serverless computing. This is a new buzzword in the town that has been gaining a lot of attention from professionals to rookies in the tech industry. This is partly due to the manner in which the cloud vendors have hyped the architecture. This has happened in conferences to meetups to blog posts to almost everywhere. But serverless is not just about the hype. It promises the possibility of ideal business implementations, which sounds quite pleasant to the ears and probably light on the budget as well. The objective is to focus on your application and not on your infrastructure. The objective is to reduce the time to market your application. A lot of daylight goes in implementing, maintaining, debugging, and monitoring the infrastructure. If we keep all of that heavy lifting of the infrastructure out of the way, we can just focus on business goals our applications will serve. So, does serverless computing mean that there are no servers? Absolutely not. Now, this is a misnomer. It just means that the cloud provider dynamically manages the allocation and provision of the servers anytime you push the code. That means that you do not have to keep the servers ready for your code deployment. It's the cloud provider that creates and manages the servers for you when you trigger the code deployment. Azure provides serverless services in several types. Azure provides serverless service in the form of Azure Functions, Azure Logic Apps, and Azure Event Grid. Remember, the objective is to make sure that you do not spend your time in maintaining the servers, creating and configuring the infrastructure. But you just have to focus on your code, so when your code is ready, you just push it
to the serverless infrastructure. So that ways you can just focus more on the code and not on the infrastructure behind it. Development and operations are two different roles in an organization. The development team works on the core aspects of the application design, coding, and version control of the code, whereas the operations team assists the development team to provide them with the infrastructure they need to host and deploy the application. And they always have been two independent entities. With DevOps, the people in the teams and the technologies used by them come together with the help of stronger processes. This nature of work provides continuous value to end users. DevOps model is a cultural change to an organization. With DevOps model, the dev team and the operations team are no longer working in silos. They work as a single team where the engineers work across the entire application lifecycle, from development to test to deployment of operations, and they develop a range of skills that is not limited to a single function. These teams use practices to automate processes that historically have been manual and slow. They use a technology stack and tooling which will help them operate and evolve applications quickly and reliably. These tools also help engineers independently accomplish tasks that normally would require help from other teams, and this will further increase the team velocity. Azure provides tools for automation using DevOps, such as Azure DevOps Services and Azure Dev Test Labs. Azure DevOps Services is formerly known as Visual Studio Team Services. This provides development collaboration tools, including high-performance pipelines, free private Git repositories, configurable Kanban boards, and extensive automated and cloud-based load testing. Azure Dev Test Labs is a service that will help developers and testers quickly create environments in Azure that will be minimizing waste and also controlling cost. Users can test their latest application versions by quickly provisioning Windows and Linux environments using reusable templates and artifacts. You can easily integrate your deployment pipeline with DevTest Labs to provision on-demand environments. With DevTest Labs, you can scale up your load testing by provisioning multiple test agents and create pre-provisioned environments for training and demos. So remember that the DevOps services is provided by Azure in the form of Azure DevOps Services and Azure Dev Test Labs. By this time, you know that you can create different kinds of resources in Azure. For example, you can create a virtual machine, a storage account, a load balancer, virtual networks, and this list can just go endless. In the previous videos, you noticed that I was creating resources in Azure with a GUI. To do so, I navigated to portal.azure.com in the browser and selected the resources I wanted to create. However, GUI is not the only way to create resources, and sometimes the administrators and developers would like to automate the deployment using a code with PowerShell, Azure CLI, or Cloud Shell. In the next set of videos, I will demonstrate how you can write a code to deploy resources instead of navigating through the GUI. In this video, let's learn how to create resources using PowerShell. First thing that I'm going to do is launch the PowerShell and then log into Azure using the Azure account. Once that is done, I will create a resource group, and in the resource group, I'll create a virtual machine. I've launched PowerShell here, and to log into Azure using PowerShell, we need to type this command called login-azure rm account. Just hit enter, and it will give you a pop-up where you can type your subscription details. Enter your credentials. It will take a minute to get authenticated. Once it's authenticated, you should see the authentication details on the screen, including your subscription ID and the tenant ID. Now you're ready to create a resource group in your subscription. To create a resource group, you just have to say new -Azure RM resource group. Give it a name. And let's say the name of the resource group is payroll, and You may want to create it in a location and give a location name. Once that is done, hit enter. It should not take more than a minute to create the resource group. The resource group called as payroll is ready, and now it's time you can create a virtual machine in your subscription in the payroll resource group. To create a virtual machine, all you have to do is just type new-azure rm VM. When we don't know what the syntaxes are, you can always seek for help using the help syntax and just suffix it with examples. PowerShell has an inbuilt manual to create or help you create a virtual machine, and there are certain examples as well. This example here will let you create a virtual machine, whereas this example 2 will let you create a virtual machine from a custom user image. You can hit enter to see more details and more examples. There's a third example here to let you create a virtual machine from a marketplace image without a public IP. I suggest that you spend some time going through the example so that you get familiar with the PowerShell syntaxes. In this case, let's go ahead and create a simple virtual machine. I'll cancel this and clear the screen. To run the same command, new-azure rm VM, give it a name. The name of the virtual machine, let's call it as a web server, and this will be in a resource group called as payroll, because that's the one which we just created. And let's create a Ubuntu image. And this will be Ubuntu LTS is the image. Let's hit enter and see what happens. It's asking for credentials, and this means that the credentials that I type in here will be used as an admin in that VM. So if I ever have to log into that Ubuntu virtual machine, I will use this set of credentials. Okay, so these credentials are injected into the image. My virtual machine will be created pretty soon. If there are any errors, then it will show up right on the screen. It will create all the resources that are required for the virtual machine to be created. While it is doing, let's go ahead and launch the Azure portal using GUI and see if it's actually doing something. I've already logged in to the Azure portal using my Firefox console. I'll refresh this page and then go to resource groups. I must have a resource group called as payroll, and in that I must have my virtual machine right here. So my virtual machine called as web server, the network card, security group, public IP address, and everything that's required for the virtual machine is ready. You can now connect to the virtual machine using its public IP. You can either do SSH, PuTTY, or use one of the tools that will be helpful to you to connect to the Linux box. The virtual machine is ready. It has a public IP, and you can connect to it, make it a web server, and put that in production if required. In this video, we learned how to create a virtual machine using PowerShell. In the next video, let's see how you can create it using CLI. Let's learn how to create a virtual machine in Azure using CLI. I've got the command prompt open right here, and if I type AZ on the screen, I should get a bunch of syntaxes. And if I get those syntaxes, it means I have Azure CLI installed. You need to install Azure command line interface before creating a virtual machine. So you can download the Azure CLI binaries by going to your search engine, typing download Azure CLI, and then clicking on this link which says install the Azure CLI. You can download the CLI for Windows, Mac, and Linux, and there are different binaries for every Linux flavor. Once it is installed and completed, you can just go to command prompt and type AZ, just like the way I typed earlier, and then you should be able to see various syntaxes that you can use with AZ CLI. Let's go ahead and create a resource group and then a virtual machine in the resource group with this CLI. I'll clear the screen and then type AZ group create, and then I need to give a name which will be --name, and all you have to do is type the name of a resource group. When we are doing the same with PowerShell, we gave payroll as the name, but let's this time create a different one, IT business. And this will be created in a location called, let's say, Central US. Hit enter, wait for a minute. But remember, we did not log in here. We should use AZ login to log in first, because the authentication will only happen if you pass your credentials. So first thing that we do is AZ login, and this command here, AZ group create, must return some error message that authentication is not done. Yeah. So get token request 400 server response invalid grant. The refresh token is expired. So I will use AZ login to get a new token. So it's launched the browser automatically. I will choose my credentials. This will automatically close and take me back to my CLI. Okay, so looks like authentication is done, and I have my tenant ID. Yeah, that's right. You always need to verify, because in your organization you may be managing multiple tenants. Make sure that you are authenticated to the right tenant. Okay, now that authentication is complete, I will then run this command again to create my resource group called IT business. There you go. My resource group is created. I can go back to the browser and click on my portal to verify if my resource group called IT business is there. Right there, it's created. Now let's go ahead and create a virtual machine inside this. At this point, I have nothing. It's a new resource group. In the command line interface, I'll run AZ. So I need to create a VM. So it should be followed by a VM create -- name. And the name of the VM is, let's say, web server 2. I'll put this in my resource group called IT business. And so we'll use this option -image win 2016 data center. I'll also pass the username who will be logging into this machine called root admin, and similarly a password for this --admin password, which you can pass right here on the screen. Okay, so I've used that. And then now you can pass multiple syntaxes like this, but I'll just stop here, hit enter to see what happens. Okay, looks like something is happening. Okay, looks like the virtual machine is created. It's got a private IP and a public IP right here on the screen. Let's go to the graphical user interface in portal.azure.com and see if it exists there. I can currently see that there are no resources here in this resource group, but let's go ahead and refresh it. Now, a new server called web server 2 is there. The virtual machine is ready. The network security group, IP addresses, virtual network, everything got created. So we really do not have to go through the graphic user interface to do next. That's time consuming, but if you have some kind of a script ready like this, you can pass this script to the Azure console via the CLI and save a lot of time for yourself. It's good for automation. Now, if I go to my virtual machines, that's a Windows-based web server. And if I go to the networking section, I must have port number 3389 open so I can RDP to this web server. I will also show you how can you open ports using Azure CLI. So I will launch the command line one more time, and then this time let's go ahead and open port number 80 on the same virtual machine. To do so, I will run AZ space VM space open -port, and then you just specify the port number that you want to open, which is 80 in this case. And then I want to specify the resource group as well, and the resource group name is IT business. VM name is web server 2. Right, hit enter, give it like a few seconds, and you must see, okay, so I've not used --port, so I should be using --port right here. I'll go back and fix this --port, run it one more time. So yeah, we got few error messages because I was not using the right syntax. I was missing a hyphen here, and --port was missing, and a hyphen before the name was also missing here. So if you scroll up to the top, I was using a single hyphen and a single hyphen for the port as well. So now I changed it to double hyphens and then a double hyphen for this as well. So switching from PowerShell to CLI is sometimes not cumbersome, but you must make it a habit, because PowerShell accepts a single hyphen, but CLI needs double hyphen to pass your syntaxes. Right now I've used this command here with the syntaxes, to open port number 80 on the virtual machine called Web Server 2, which is located in the resource group called IT Business. Let's give it a minute and it should be ready. Looks like the port is open. Let's go to the GUI and verify this. So I'll just refresh this page and I see that port number 3389 along with port number 80 is now added as a rule in the existing security group. So with CLI, we were able to create resource groups, create a virtual machine, and also open the ports in the virtual machine. You can do a lot of things with CLI and PowerShell. You can install IIS inside this virtual machine as well. It's not just virtual machines or resource group, but you can create every resource and manage every entity inside Azure with CLI and PowerShell. In the next video, let's learn how to create resources using Azure Cloud Shell. In the last two videos, we saw that we can create resources using PowerShell and also with Azure CLI. For that, you had to download and install the module for PowerShell and the command line installer for Azure from the Microsoft website. But what if you do not have permissions on your laptop? You may have a corporate owned device and then you may not be able to install something on your device because of permissions. For that reason, Microsoft Azure has an inbuilt Cloud Shell on the portal, which can be invoked by clicking on this little icon that looks like a command line icon here. If you click on it, it launches a screen that looks similar to a command line. You need to create a storage before you start running your commands and scripts inside this Cloud Shell. This storage is to make sure that all your commands are stored inside your storage account for a longer period of time. You do not have to authenticate yourself because it's all done automatically. As you have already logged into the Azure portal from the browser, it will pick up those credentials to create a storage account for you. Within no time, you should be able to see a storage account under the storage account section. If you delete the storage account, all your commands and scripts stored in the storage are also gone. At this time, it is initializing your account, but remember that you can run both PowerShell and CLI based scripts and commands in one screen. You do not need two screens for that. So you can switch between PowerShell and Bash. Now, Bash is nothing but the CLI based scripts, whereas PowerShell is the PowerShell based scripts. So depending on what you want to run, you may pick and choose PowerShell or Bash. Now we can run the same commands like creating a resource group and then launching a virtual machine using the PowerShell. And I'm just going to demonstrate that to you in a minute once the authentication is complete. So it looks like the authentication is done, and we also have a storage account for storing all the Cloud Shell based commands. Now I can first go ahead and create a new resource group using the command called new-Azure RM resource group. And the name of the resource group is IT department. Let's say it is IT department, and it's in a location called Central US. Hit enter, give it a minute for the resource group to be created. Now since that is done, let's go create a virtual machine in this resource group. Now, before I start running the commands for creating a virtual machine, I will store my credentials in a variable called as $cred. $cred is nothing but a variable where the credentials will be stored. Now the reason why I'm doing this is to make sure that the new Windows machine that I'm going to create will have these credentials as the local admin and password. So this username called root admin will be the local admin on the Windows machine, and the password will be used to log in to the Windows based machine. And now I can use this script right here, which I already have in my clipboard. I'm using this command called new-azvm. It will be created in a resource group called IT department. The name of the machine is web server with all of these parameters. And then in the end, I'm passing a syntax called -credential and then using $cred variable, which was used earlier. That means these credentials will be passed on to this virtual machine for local login access. I'll hit enter and wait for some time for the virtual machine to be created. Looks like work is in progress. So if I go to my resource group right here, there's a resource group called IT department. Click on it, and under overview, I must be able to see all the resources that are getting published inside my resource group. The name of the machine is web server 1. It's got a disk ready. public IP address, the security group, and you will see that all the dependencies that are required for the VM to be created will be provisioned in some time. It's just not about creating virtual machines, but you can manage the entire set of resources, everything that Azure can let you build, including app services, databases, load balancers, web application firewalls, virtual networks. Everything can not just be provisioned but also managed. You can restart instances, stop virtual machines, install applications inside your virtual machine. So there's a lot that you can do with the Cloud Shell. In the next video, I'll show you how you can pick up a JSON template somewhere from the internet and use that to provision resources in Azure. When engineers and businesses have access to Azure portal, they will create resources like virtual machines, storage accounts, AI, IoT, and everything that's available in Azure. But there must be some kind of a service that provides recommendations and tells you, hey, this is what you're doing wrong, and this is what you can do better. Azure Advisor is a service that does just that. It acts like a personal consultant, providing you recommendations on various important entities like high availability, security, performance, and cost. Azure Advisor analyzes all the deployed services in Azure and looks for ways to improve your environment across all of these areas. Once Azure Advisor looks at the environment in Azure, it will give you proactive, actionable, and personalized best practice recommendations. Now, such recommendations will help you improvise on your performance, security, and high availability of your resources so that you can identify opportunities to reduce the overall cost. Once you have the recommendations, you can download the Azure Advisor recommendations in the form of PDF or CSV format, and then you can share it to your colleagues. As you see in the screenshot here, you can see that there are 8 recommendations in high availability, 21 in security, performance 1, and cost optimization 2. Now, these 4 highlighted areas are also called as the pillars of well-designed architecture. So when you design solutions in Azure, we must have these 4 important points considered so that your organization gets the best as far as the return of investment is concerned. These are the 4 categories which the Azure Advisor looks at and provides a recommendation in each of those important categories that Azure thinks is an opportunity to resolve an issue. You can select the recommended action for a recommendation to implement, and there are simple interfaces that will open and help you implement the recommendations as well. Each of the recommendations are then followed by documentation, which you can then take it forward to implement. So Azure Advisor is your personal consultant that looks into your infrastructure in Azure and provides recommendations in these 4 important areas. Please read the important features of Azure Application Gateway.
Now that we know different kinds of data like structured data, semi-structured data, and unstructured data, let's understand how Azure can accommodate these 3 kinds of data. Azure provides storage in the form of blob storage, disk storage, file storage, and archival storage. The blob storage is meant for unstructured data. That means there are no restrictions on the kinds of data it can hold. These blobs are highly scalable, and that means that you can put just unlimited amount of data inside it. The applications can then use the data for reading and writing purposes. Blob storage are very powerful. That means they can manage thousands of concurrent loads, massive amounts of video data, and constantly growing log files, and they can be reads from anywhere just with the help of an internet connection. A blob could contain gigabytes of streamed data for any purpose. It could be for scientific instrumentation purposes or for mechanical industry. The disk storage provides disks for virtual machines, just like the name says. It provides disks for virtual machines, applications, and other services that may need it, just like your on-premise environment. Disk storage allows data to be persistently stored and accessed from an attached virtual disk. So every time you create a virtual machine in Azure, the storage account which will be provisioning the disk, will be inside a disk storage. A file storage is used to manage file shares. Now these file shares are accessed using SMB protocol. Azure file shares can be mounted concurrently by cloud or on-premise deployments of your Windows, Linux, or even Mac OS. Applications running in Azure virtual machines can mount a file storage share to access file data. Any number of virtual machines can mount and access the file storage share simultaneously. Archival storage, as the name says, it provides a storage facility for the data that is rarely accessed. It allows you to archive legacy data at low cost to what would traditionally have cost to create and maintain archives. Archive storage is available as a tier of blob storage. Archival storage is stored offline and offers the lowest storage costs. However, it also has highest access cost. That means that you should not be accessing the data in the archival storage very frequently. In the next video, let's go ahead and do a demonstration of how do you create a blob storage and how it can be used for business purposes.
In this module, we learned about the core Azure architecture components. For example, how Azure data centers and services are located, how they are organized in regions and geographies. We also learned about availability zones and availability sets. Then we gained an understanding of how you can automate the deployment and configuration of resources with JSON, PowerShell, and Azure CLI. Finally, we learned how to use resource groups for managing resources in Azure. We also learned about core Azure services and products like virtual machines, Azure Container Services, App Services, Kubernetes Services, virtual networks, load balancers, content delivery networks, and application gateways. Various Azure solutions were also discussed like IoT, HD Insight, data analytics, etc. We also spoke about serverless computing services like Azure Functions, Logic Apps, and Event Grid. An introduction to DevOps and how Azure provides DevOps services in the form of Azure DevOps and Azure Dev Test Labs were also discussed. We also talked about Azure management tools like Azure Portal, Azure PowerShell, Azure CLI, and Cloud Shell. To end with, we discussed about Azure Advisor, which is your personal consultant providing recommendations on high availability, security, performance, and cost. Apart from creating resources using PowerShell, Azure CLI, and Cloud Shell, you can also create resources using Azure Resource Manager Quick Start templates. Now what are they? Azure Resource Quick Start templates are in the form of JSON, which are available in this library called as Azure Quick Start templates. You can go to this URL called azure.microsoft.com/resources/templates, and then you will find a lot of templates created by people like you and me. At this moment of recording, there are 796 Quick Start templates. Now these templates will help us create resources in Azure. Now you do not have to write a template from scratch because these templates are available right here. Now because these templates are created by non-Microsoft people, well, some of them are created by Microsoft people as well, but it's always a good practice to go and look into the content of the template to see if it's doing the right thing or not. Now, what is it that you can deploy using the Quick Start template? Well, most of the configuration is right inside this little box, but then you can just read this header and identify what it's doing. For example, in this case, it is deploying a simple Windows virtual machine. So let's dive into it further. I'll click on this little box here which says it will deploy a simple Windows VM. It is created by a person called as Brian Moore. Now, if you scroll down, it is setting certain parameters like username, password, DNS label prefix, Windows OS version, and location. The author of this template has also written how do you call this particular template using PowerShell. And if you would like to use CLI, there's a CLI method as well. But where is this template? What is the script doing? At the end of this particular command, you will see a syntax called -template-URI. The URL followed by this syntax is what's in my interest. You may either click on this or click on this little box which says browse on GitHub. If you click on it, it will redirect you to github.com, and then there is a file called Azure deploy.json. Click on it further, and then it will show you the template that will be used to create a virtual machine. You can click on raw here to see a plain non-HTML version of the template. This file that you see is a JSON file, which is written here as well in the address bar, Azure deploy.json. Most of the templates are written in JSON today because that is a widely accepted template platform. In this case it is creating an admin username. The name of the admin is not mentioned inside this particular syntax here. So when you call this template, it will be giving you a pop-up. So you will understand this once we start executing it in a minute. Similarly for the password as well. The author has not typed the password inside this template for security purposes. That means when you call this template, you will get a pop-up to type in the password. And again, we'll see that in a minute. The same holds true for DNS label prefix. There are lots of variables that are defined inside this JSON template for us to create a virtual machine. The parameters are the public IP address, virtual networks, network interfaces, and everything that's required for a VM to be healthy and ready. Let's go ahead and launch either PowerShell or Cloud Shell to call this particular template. I'll navigate to the Azure portal here and then click on the Cloud Shell icon to launch my Cloud Shell, so I can then use PowerShell or CLI to call my JSON on the internet in the Azure GitHub. Okay, so that's ready. Now we can start writing the command, or maybe just go to the author's webpage in the Azure Resource Manager templates and copy this particular command from there. Again, you can either use CLI method or a PowerShell method. Okay, so I will just copy this part. So it is creating the first line here, AZ group create -name, resource group name in the location, right? So this is the first thing that we have to do. So I will just copy this part, go back to the resource group and paste it here. Alright, so it got executed too early. Name, the name of the resource group, you can just type something and put that in a location, let's say East US. I'm just creating a resource group for now. There's an error, let's go fix it. Now always remember, whenever you're using a CLI method, we gotta use double hyphens. When we use PowerShell, it is single hyphen. So when you switch between PowerShell and CLI too often, that's the problem. Let's hit enter again. Now what's the problem here? Hyphen location. Now, this is case sensitive. It really doesn't like uppercase. Let's give it a try one more time. The syntaxes must be as is. No uppercase is allowed. Okay, so looks like the resource group is created. You can go back to the portal and verify that. I'll fix this. Okay. I just refreshed the browser and I noticed that there is a resource group called IT business that's just got created. Let's go call this JSON from the shell. So the next command here is AZ group deployment create -- resource group, which is IT business. All right, and then my template URI. My template URI is as is. Okay. If you like, you can go ahead and modify this path, put your own JSON, modify the JSON as per your requirements, and then call it. I will hit enter to see what happens. Please provide string value for the admin username. Remember, if the admin username is not hard-coded in the JSON, it's going to ask you for it because these are mandatory values. Okay, let's type root admin, give it some complex password, hit enter. DNS label prefix. Yes, let's give it some DNS label. Okay, hit enter. And then just wait for some time. It should have a virtual machine created in the resource group called IT business in East US. As you see, it is running. I will resize the Cloud Shell so that we can get a better view. It took about 5 minutes
maybe 4 minutes to get this provisioning state to be in succeeded state. And as we see in the background, we have a new Windows virtual machine. So it was a hands-free deployment. We never had to touch the graphical user interface, and you could call the JSON template from PowerShell, CLI, Cloud Shell, doesn't matter, as long as your template is healthy, as long as your template does not have any syntax and grammatical errors, the PowerShell or CLI would be able to call the JSON. The objective of the JSON is to make sure that you do not have to rewrite the code again and again. So if you ever have to redeploy this, all you have to do is just copy this and paste it right here on the CLI or on the PowerShell. So you don't have to redo and recall everything. All your settings that are defined for the virtual machine goes inside the JSON, and you save the JSON somewhere in a script repository or somewhere. And you call the JSON using a PowerShell or CLI, and that way you save a lot of time. So in this set of videos, we learned how you can create virtual machines and other resources using PowerShell, CLI, Cloud Shell, and how do you call a JSON template using PowerShell. Let's start this chapter with an understanding of what cloud computing is. Today, cloud computing has become a buzzword. Most of the enterprises and small and medium business companies use this term probably without an understanding of it. In this chapter, we learn about what cloud computing is and what benefit it has to offer. Traditionally, if we ever have to build applications, we had to procure a lot of hardware. For example, you will need servers. You'll need operating systems and their respective licenses. You will need firewalls, routers, switches, load balancers, databases, and the list just goes endless. And that means that you will need a lot of capital expenditure. Capital expenditure is the amount of money that you will invest initially to procure that hardware. On the other side, operational expenditure is what you will need to maintain that hardware. For example, heating, ventilation costs, electricity costs, human and manpower, payroll costs. All that is operational expenditure. With traditional computing, both CAPEX and OPEX, which is capital expenditure and operational expenditure, both of them were high. And today, with the advent of small and medium business companies and startups, we really do not have the scope to invest so much on the hardware or licenses for the operating system. So what do the startups do to provision their infrastructure to let the business run? What do they have to do? Well, they have to resort to something called as cloud computing. This is where the whole bunch of resources will run. So the startups will simply put their resources, for example, servers, storage, databases, networks, softwares, artificial intelligence and their respective analytics, everything into cloud. Cloud is nothing but a massive, huge, humongous data center that is maintained by the cloud provider. For example, Microsoft or Amazon or Google Cloud for that matter. And cloud providers will make sure that the services that are offered to you will have a faster way of delivery. They innovate faster, the resources will be flexible, and you can definitely scale the resources as and when you want. And the best part is the CAPEX and OPEX really falls down exponentially. You typically pay for the cloud services only what you use. So you only will have very low operating costs, your infrastructure will be running more efficiently, and you can scale your business when it's required. Let's look at the definition of cloud computing now that we understand cloud computing. Definition of cloud computing is given by a body called as NIST. NIST is National Institutes of Standards and Technology, and they defined the definition of cloud computing in their publication 800-145. And here is the definition. It says that cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider's interaction. What does it mean? It means that I, as a cloud user, should be able to create a virtual machine, create a server, storage, maybe an SSD or an HDD or any kind of application whenever I want it. When I want to provision them, when I want to create them, probably in the middle of a night, I get an idea and you want to create a server right then, you should be able to do it. You should not be calling up the call center of Microsoft or Amazon Web Services, standing in the queue, and when the call center executive picks up the phone, you then say, hey, can you help me create a VM? Make sure that has 8 GB of memory, that has 40 terabytes of hard disk, make sure that port 22 is open. We're not going to do that, because today we have our own self-service provisioning portal where you can type in your user ID and password, and then you enter into the world of cloud services provided by the cloud provider, which could be Amazon, Microsoft Azure, or Google Cloud. So you will be able to create resources as long as you have internet, as long as you have a device that supports a good browser. That's all you need to maintain the most sophisticated infrastructure in the world. So no more procurement of devices, no more maintaining them. You really do not have to pay the electricity costs or air conditioning costs. It's all done by your cloud provider and they maintain it, but you just have to pay as you use it. It's more compared to the utility computing. For example, the electricity bills at your home that you get, you do not pay the whole bill at once. You do not pay for the transformer costs or the supply lines. You just pay based on your usage. This is exactly what it is, a simple analogy that can be used. I'll also give you a simple definition that was given by the federal CIO, and here is the definition. I would like you to read it, give a minute, and see how simplistically the definition of cloud computing has been brought up to you.